I cannot figure it out.
Yeah.
Hey, why was I marked absent unexcused? What are you talking
I didn't see you sitting there, I'm sorry. My bad.
You have a color club? And you?
I'm confused now with so many more chairs. Like I looked back in the corner and I didn't see it.
Yeah, no, I said I had to because you guys wanted to load the ground next to the bed, so it's.
Okay. So, I got lots of requests to go over the homework from yesterday, so let's just talk about it for a few minutes here. So first, let me just review IVT and EVT. So IVT is the intermediate value theorem. It just states that if the function is continuous, you can't get from here to here without hitting every y value in between. All right, so it just states that no matter what, like if I take any horizontal line that's between this y value and this y value, like any horizontal line at all has to be crossed in order for this to work in a continuous way. That's what IVT says. EVT is the extreme value theorem, and it just states that if you have a continuous function, it has to have a max and a min. So in this case, the max would be like there, and the min would be here at the endpoints, but they might be somewhere in the middle, okay? That's what EVT says. IVT says you have to hit every y value from here to there, and EVT just says if you have a continuous function, it has a max and a min. So let's look at the way that these questions are worded. These questions all dealt with inferences from tables. So they're giving you a table, and they want to know like what that table says about IVT or EVT. So like with the IVT section, what you're going to be looking for is the word continuous. If they don't give you the word continuous, then you know that the IVT doesn't necessarily work. And same thing with EVT, okay? So they're saying you have this continuous function. That means that the intermediate value theorem works. And it says, oh, that's weird. It says it is known that f prime of x is negative. Oh, nobody knows what that means, do you? Oh, that's a problem. All right, so let's just talk about that for a second. F prime, it just means the slope of the curve, okay? So if the slope of the curve, and what slope of the curve means is we'll talk about at a later date, but we know what a slope of a line is, right? It's just the rise over run, right? So slope of a curve is kind of the same idea. So if the slope of a curve is positive, that just means that it's going up from left to right in a like a strict way, like it's never going down, right? So a function where f prime is positive might look like this, okay? It could have curves in it and stuff, but anywhere you look, it's increasing the whole way. So this is what's happening if f prime of x is positive, and if f prime of x is negative, it's just strictly decreasing from left to right. This is f prime of x is negative. Does everybody understand that? Okay, so now that we have that understanding, let's look at the question. I wasn't aware that those types of questions were on. All right, so they're telling you that this function is strictly decreasing, okay? And you can kind of see that the y values are decreasing, but they're telling you that's strictly occurring. Like for every time the x value goes up, the y value goes down. That's what they're telling you, okay? Determine the validity of the following statement. It says f of x equals 3 has at least one solution in the interval from 1 to 5. Is that true or false? I mean, let's graph the situation. The situation says f of 1 equals 2. That's that point. F of 4 equals negative 1. That's that point. F of 5 equals negative 4. That's that point. Does it have to be true that there's a point between here and here where f of x equals 3? No, especially not if the function's strictly decreasing, which it says it is right here. That means it goes from here to here. It might do little wiggles, but it has to be going down the whole time. It's impossible for it then to equal 3 somewhere in that interval. It's impossible for it to cross this line if it's strictly decreasing from here to there. Do you agree? And so if you look at the choices, this statement has to be false. It can't possibly be true. So you just click this statement must be false, which is that choice, right? And you can see that that's the answer, okay? So I can see why this gave you some, sorry about that. Let's try another one. So again, they're telling you have a continuous function. That means the intermediate value theorem works. And it says, determine the validity of the following statement. F of x equals 0 has at least two solutions in the interval from 1 to 6. Well, if you're going from 1 to 6, you know that it can't get, the y value can't go from 4 to -4 without crossing 0 somewhere in between. That's what the intermediate value theorem says, right? It says if it's 4 at one point and it's -4 at another point, it can't get from here to here without crossing that. That's the direct statement of the intermediate value theorem. It has to cross it at least once in that interval. It has to equal 0. Do you agree? And then again, it can't go from -3 to 2 without crossing 0 somewhere in between. It has to equal 0 somewhere in there, right? Now, these other intervals don't really tell you anything about 0 because it's just going from -4 to -4 and from -4 to -3. So that doesn't necessarily mean that it has to cross 0. But if it goes back from -3 to 2, there's no way you can get from here to there without crossing 0 twice. So this statement is definitely true. It has at least two solutions. Now, it might have more. Maybe the function goes like this. It crosses that point, and then it goes, woo, and then it comes back down. And it's like that. We don't know that that's what it looks like, but it might. That's why it has to say at least two solutions. That make sense? So the correct answer here would be, this statement definitely must be true. There has to be at least two solutions. Okay? Let's look at another one and just see if there's something different. This is the same type of question. So what do you think is the answer here? Is it true, false, or it could be either? Has to be false? It might be false, but it could be true. Maybe it's true, right? I mean, picture the points. Like, I'm going to do the same thing. I'm going to graph the points. -3, 1 is like here. -2 is like here. 1, -2 is here. And 4, 1 is here. Bless you. F of x equals -3 is like down here. So, yeah, it's possible the function just goes like this, maybe, but it's also possible the function goes like this, right? So, in this case, the statement would be true in the red function I drew. In the green function I drew, the statement would be false. It could be true, it could be false, depending on the missing values that they're not showing us. So I would say the statement could be either true or false. Does that make sense? So what I'm doing when I'm solving these problems is I'm looking at the y values and I'm deciding, is the y value that they're giving us here, is it like in between two of the y values here? And if it is, then that means that the intermediate value theorem definitely works and there has to be at least one point, blah, 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 blah. If this number is not in there and it says continuous, well, maybe it works, maybe it doesn't, okay? Now, when would the answer ever be, has to be false? I don't know that it ever will be, okay? It doesn't seem like I can't think of an example right now when the answer is false. Oh, that first example we did, where they told us that it's strictly decreasing, or they tell us that it's strictly increasing. Then you know, like, what it's kind of what it's doing. You know it's not dipping down and doing some weird stuff, right? that's when the answer is going to be false. All right, let's just do one more. So here again, they're telling you it's strictly decreasing. So is this true or false? F of x equals 10 at least once. This one would be false because it's strictly decreasing. If it's strictly decreasing, it's never going to be bigger than 8. It's always going to go down from there. So this one's going to be always false. Okay? Does that give you a better idea of this assignment? Okay, so then the second part of the assignment was extreme value theorem. And let's see what types of questions they give you on that. Of course. So the extreme value theorem. So again, they're telling you it's continuous on a closed interval. That means there's a max and a min. So it says f has a max on the interval from 2 to 10. Absolutely, that's true. We don't know what it is necessarily. We don't know that it's necessarily 55. Maybe it goes up between here and here. Maybe it goes up to 56 and then comes down to 55. So we don't know exactly what that max is, but we know there is a max. That's what the extreme value theorem says. So this statement definitely has to be true. Okay? Let's look at another one. So again, here's this f prime is less than 0. What does that mean exactly? It's decreasing from left to right. And you can see that's what's happening, but they're telling you it's happening strictly. So it says selected values of the function are shown in the table below. The function is differentiable. That just means that it doesn't have any weird like corners or asymptotes or anything strange happening. And so they want you to answer whether the maximum value of f is 6. Does that have to be true, or could it be true, or does it have to be false? It has to be true, because that's the leftmost point, and this function is strictly decreasing from left to right. So if that's the leftmost point, that's the leftmost y value, that's the highest it possibly gets, and that's what maximum value is. So this statement's definitely true. Okay, let's see if there's a different type of question. So this one, they don't say anything about increasing, decreasing, strictly anything like that. They're just saying it's continuous. So the maximum value is -9. True or false, or could be either. Could be either, right? That's the largest value that appears on the table. But that doesn't mean that it doesn't start here and then go up and then go back down. Like it could be -8 and then -11. Like at 1/2, it could be -8, in which case the maximum value would be -8. So this is one that could be either true or false. Either true or false. Is this helping? Let's look at another one. This means strictly increasing, right? The derivative is positive. That means that it's sloping up from left to right. Okay? So they want to know, is the maximum value 14? Who thinks it's true and who thinks it could be true? True? Right. Could be true? I think it's definitely true because it's strictly increasing. In other words, this is the lowest it possibly gets. This is the highest it possibly gets. It's strictly increasing from y equals 6 to y equals 14. The maximum value is definitely 14. That's the highest it possibly gets. That makes sense? It can't do this because then it has a little section where it's sloped down, negative. Right? So this one has to be true because it's strictly increasing. Must be true. Okay? Okay, it said, oh, this one looks great. Okay. So this one says, there is a number, C, such that on this interval such that f of c is greater than or equal to f of x for all x. In other words, c is where the maximum occurs. And the maximum value of the function is f of c. That's what they're saying. So they're saying, true or false, this has to be continuous. Oh, okay, so this is a little bit weird now. Now they're saying, like, what the extreme value theorem says. The extreme value theorem says, if you have a continuous function, then you have a max and a min. That's what the extreme value theorem says. They're saying, is it true that the converse of that statement is also true? Which is, if a function has a max and a min, then it has to be continuous. You see, those aren't the same thing, right? In general, like a conditional statement and its converse are not the same, right? Like if I told you, if it's raining, then I'm happy, right? That's not the same thing as saying, if I'm happy, then it's, what did I say?
Raining.
Oh, that's a terribly false statement. If it's sunny out, then I'm happy, right? That's not saying the same thing as if I'm happy, then it's sunny out. Maybe it's nighttime and I'm just happy because I've been drinking or something like that, right? That's possible, right? So yeah, or if you study really hard, then you'll pass. Okay, the converse of that statement is, if I pass, then I studied really hard. Maybe I cheated. Maybe, you know, it was just super easy for me and I didn't study at all and I just passed, right? So a conditional statement and its converse are not saying the same thing in general, and that goes for here too. This is saying, just because of this function has a max value, it has to be continuous. That's not true. I mean, I could have a function that literally is only these points. Only these points. There's a max right there. But is this function continuous? Definitely not, right? I definitely had to lift my pencil to draw this whatever it is, this function. So this statement could be true or it could be false. Who knows? But it's the converse of the extreme value theorem isn't always true, but it could be true or false. Let's see what the explanation is. They probably give something like this. Oh no, they don't. I thought they were going to give a graphical example, but they didn't. Does everybody understand? Okay. I can see why this was a challenging assignment. I apologize. Hopefully you didn't stress over it too much. Raise your hand if you stressed over it a lot. Good. It's just math. Don't worry about it. All right. So we're going to move on. Any questions on that? Okay. Let's move on. All right, so today we're going to talk about the average rate of change of a function. Okay, so here's the deal. The average rate of change of a function over an interval A to B is the slope of the segment between the points A, f of A, and B, f of B. All right, that's what the average rate of change is. It's just the slope of the segment that connects those 2 points on the graph. So, like for example, if I have a function f of x, it goes like this, f of x. And I'm trying to find the average rate of change from A to B. So this point right here on the graph would have coordinates A, comma, f of A, right? And this point right here on the graph would have coordinates B, f of B. So the average rate of change would just be the slope between here and there. Okay, that's the average rate of change. The slope, which I know what the slope formula is. It's just change in y over change in x, right? It's like delta y over delta x. So you subtract the y's, f of b minus f of a, and then you subtract the x's, b minus a, right? That's how you calculate slope. That slope is the average rate of change of f of x on the interval for b to b. So they're either going to give you a graph or they're going to give you a table of values, and they're going to ask you to calculate average rate of change. Like, for example, if they give you a table, it would look like this. They'd have like x, f of x. They give you some x values, like maybe like 1, 3, 5, 7, and some y values like -2, 0, -3, 5, something like that. And they would say, find the average rate of change of f of x on, and then they'll give you an interval. Maybe they'll say the interval is from 3 to 7, something like that. So you have to like pick and choose which lines of the table you're actually going to look at. In this case, I'm going to look at the line dealing with x equals 3, line dealing with x equals 7. And all I'm going to do is I'm just going to subtract the y's and subtract the x's. Think of this as like 2 points that they're giving us, 3, 0, and the 0.75. To find the slope between those 2 points, you subtract the y's, you subtract the x's. That's all we're doing here. The average rate of change, here's your answer, average rate of change would be 5 minus 0 over 7 minus 3. So this would be 5 halves, or 5 fourths, right? 5 fourths. That's the answer. Now you might be wondering, like, what if I subtract them in a different order? You'll get the same thing. Like if I subtracted these by taking this y value first, as long as I'm consistent and take this x value first, I'll get the same thing. I'll get 0 minus 5 over 3 minus 7, which is -5 over -4. It's the same answer, right? So it doesn't matter when you're calculating slope which point you pick first as the y value, as long as you pick the same point for the x value to go first. Okay? If they give you a graph, this would be just as easy. Like suppose you had a graph. I'm going to actually use graph paper here, just so it's nice and precise. So mark graph paper here. So if I had a graph, and let's draw it so it goes like something like this. And they said, find the average rate of change of f of x on the interval from, I have to find more precise points. Let's say it was like -1 to 6. Okay, so you're going to look at your graph and you're going to find the y values that are associated with those 2 points. So this point has coordinates -1, or -1, +1. And this point has coordinates 6, 5. So the answer would just be 5 minus 1 over 6 minus -1. Remember, when you're subtracting a negative, we got to change the sign. So this would be 4/7. And that's the answer. So let's look at Delta Math real quick so you can see there's actually 3 types of problems on the Delta Math assignment. Find the assignment first. Oh boy. All right, so right here. So there's 3 types of problems. The first one is just the table, like I said. So they're going to give you a table, and here they're asking you to find the average rate of change from 3 to 8. So this would just be 2 minus 17 over 8 minus 3. That's it. -15 over 5. So this answer would be -3. So you just type in -3, and that's all there is to it. The answer, yep, that's it. Okay? Any questions on those? But you have to be careful. Sometimes they're not going to give you the first and the last term of the table. It might be some in-between terms. So read the directions carefully to see what interval that you're looking at. Okay? The second part of the assignment is where they want you to actually draw that line connecting the 2 points and then calculate the slope. So in this case, they're giving you the interval from -4 to 6. So all you would do is you would just click on the point where x equals -4 right here, and then click on the point where x equals 6 right here, and then just answer the question. So they want to know, what's the change in y? Make sure you pay attention to the scale of the graph. The change in y here isn't 3, it's actually 15, right? Because each little block is worth 5. So you'd say the change in y is 3, and make sure if it's going down, the change in y would actually be negative, right? And the change in x, in this case, the scale is just 1 to 1, so it's 6. Sorry, 10. 10 between those. So then the average rate of change is just change of y over change of x. It would be 3/10. Oh, yeah, I just said that. I messed up. Thanks. 15/10. So the answer should be 3/2, right? 15/10 is equal to 3/2. And that's it. Okay, and then the third part of this assignment, you do the same thing, except you don't actually have to write down change in y and change in x. You just have to give the answer. But again, make sure you take note of the scale. In this case, in the vertical direction, the scale is like 2 to every 1 block. So if you're going from -4 to -2, that's going from this point to this point. So you just want to know, what's the slope of that line? Well, the change in y would be -6, and the change in x would be +2. So this would be -3, slope of -3. So down here, you just go -3, give the answer, and that's it. Okay, so 3 types of questions. They either give you a table and want you to calculate the slope of the line, or they'll give you a graph and they want you to draw the line and then calculate the slope, or a graph without drawing the line and calculate the slope. Does everybody understand? Okay. We're also having a quiz tomorrow. There's not going to be a normal lesson tomorrow. Tomorrow's quiz is just going to be on types of discontinuities. So remember, there's 3 types. There's jumps, infinite, and removable. Removable just means the whole, right? 3 types of discontinuities. Also, piecewise functions and calculating whether or not they're continuous. Okay? And then just the statement of the intermediate value theorem, which is you can't get from here to here if the function's continuous without crossing every y value in between. Everybody understand? Okay. That's it. I'm going to stop it there.
So, like, are there going to be questions like what was on yesterday's?
No.
assignment?
It's just the stuff we went over last week, And the IBT assignment from last week was just those ones where they give you, like, the statement of the IBT, and you just answer the prompted questions that they give you. I would look back at that assignment if you're not quite sure what it looks like, just so you remember like how to answer those questions.
I may have to leave early around the destination.
Okay.
I can just take it before 8,
Yeah,
or do I don't have to take it like midnight?
no, you can take it anytime before 8 p.m. Yeah.
Thank you.
Yeah.
Could you go back to the top of the note?
Wait, just, I can't hear you, Tony. What's that?
Could you go back to the top of the notes?
Sure.